Hello guys, on this video I'm going to show you how to answer question 3 on Handout 3A for the class Algebra 110. Okay, so this has to do with equations and solving equations. So since we're dealing with an equation, I'm going to write you some of the steps that I have already talked about on some other videos, right? The first thing that you want to solve on an equation, or step 0 as I like to call it, is going to be fractions. Okay, and then you have to get rid of the parentheses, grouping symbols, so parentheses, brackets, or braces as well. Okay, and then the next thing that you're going to do is you're going to add and subtract from both sides of the equation, okay, until you don't have any more additions or subtractions. Okay, this is going to be combining, adding to both sides, subtracting to both sides. Okay, the last thing that you're going to do, one of the last things that we're going to talk about, is going to be multiplications and divisions, right? So you multiply both sides, you divide both sides, and then that's going to help you isolate the variable. Sometimes you have exponents, and that's the fourth step, right? Exponents. But since we're not dealing with exponents at this level, we're just going to leave it until step 3. Okay, so let's go ahead and take a look at that. Try to solve that equation. Okay, or well, before we solve that equation, let's go ahead and define what an identity, a conditional, and an inconsistent equation is. Okay, just a refresher, an identity is going to be an equation that is true for any number that you substitute in. So if you substitute 1, 2, 3, 4, 0, the left side of the equation is going to be equal to the right side of the equation. So for an identity, we are looking for something that looks like 0 equals 0, 1 equals 1, x equals x, 10 equals 10, or so on and so forth, right? As long as the left side of the equation equals the right side of the equation, then that's going to be an identity. For a conditional equation, this is going to be I want to say the most common equation, or the equation that we are more familiar with. Okay, something that we're trying to solve the equation and we reach a point where it says x equals 1. So x, or the variable that you're solving for, equals a number, just one number, one value, right? X equals 2, x equals 3, it can be x equals 0, right? X equals negative 10, or so on and so forth. X equals something, this is what we're looking for, except x equals x. If it's x equals x, that's going to be an identity, right? Because x is the same as x, those are identical. But if it's x equals a number, that's a conditional. And you might take a guess already what an inconsistent is. Inconsistent equation, that is when the left side is not going to be equal to the right side ever. We have a number on the left and a right, and they're not equal, right? So we reach something like 1 equals 2, which is inconsistent, right? Or 10 equals 12, or negative 1 equals 1. Two numbers that are different, right? Or I don't know, it can also be negative 1 equals 0. As long as those two numbers are not the same, then that's going to be inconsistent. Okay, so let's go ahead and solve for this equation. The first thing that we're going to get rid of is going to be fractions, which we don't have. So we're going to move ahead and get rid of the parentheses. And in order to get rid of the parentheses that we have on both the left side and the right side, we have to do the distributive property of whatever is in front of those parentheses, right? Over here I have a 5, and over here I have a negative 3. Remember to include the sign of the number. Okay, so let's go ahead and get rid of those parentheses by doing multiplication. So 5 times x, that's the first multiplication. And then 5 times 3, that's the second multiplication. Everything else remains the same. Then the next multiplication, negative 3 times x, that's negative 3x. And negative 3 times positive 7, that's going to be negative 21. Okay, remember I didn't write it in here, but in between these steps over here, every single time that you do one of those operations, it will come in handy if you combine like terms. Okay, so everything that has the same variable with the same exponent can be combined through regular additions or subtractions of the coefficients of the big numbers. Okay, so on the left side you can see that 15 and 12, those can be combined into one only number. So 5x, and then 15 plus 12, you just have to add those two numbers. That is going to be a 27. Okay, and on the right side of the equation, numbers or variables that have the same exponent, they can be combined by regular mathematical operations of the coefficients, the big numbers. So 8 minus 3, that's going to be 5. X, you gotta keep that variable in there, minus 21. Okay, so at this point maybe you can see that this is going to be an inconsistent equation, right? Because 5x plus 27 is not the same as 5x minus 21. They're going to be completely different results. But we can keep going, right? We can keep trying to solve this equation until you can picture that this is going to be an inconsistent equation. Okay, so I'm going to move to the next step, which is step 2 on my equation solving, adding and subtracting to both sides until I don't have any more additions and subtractions. Okay, so I'm going to start with the letters. Since I have a 5x, I want to try to send all the x's to the left side, for example. Okay, so in order to get rid of this 5x on the right side, I have to subtract 5x. And if I subtract 5x from one side, I have to do this exact same operation to the left side, and that is going to, in theory, that's going to send all the variables to the left. Okay, so let's go ahead and combine like terms. So 5x minus 5x, those are the same, so they're going to cancel out. All I have left is going to be a positive 27, or just 27. And at this point, can you see that the same thing happens on the right side? So the only thing that I have left is a negative 21. At this point, there's nothing else that I can do. I mean, I can set both numbers to the same side, but that's just going to extend the solving of the equation. I mean, we're not going to get any different outcome at that point. Okay, so I have two numbers, they're not equal to each other's. So this is going to look like an inconsistent equation, right? Two numbers that are not equal to each other's. That means that this whole equation is inconsistent. And how do I know this is inconsistent? Another way to prove it, substitute any number that you want in the x's, right? Replace all the x's for a number 1 if you want. And try to solve, or try to do PEMDAS to both sides of the equation. You're going to reach two different numbers, right? You're not going to be able to solve the equation as x equals something, like we like to see the equations. Okay, so this is going to be an inconsistent equation because we got two numbers that are different to each other. We don't have a result for this equation. This is not the result. Okay, this is not the result. This is not really equal. Those two numbers are not equal. That means that there's no graph associated with this equation, or that doesn't matter what number you substitute into those x's, you are never going to get the left side of the equation equals the right side of the equation. So go ahead and let me know if you have any other questions. Make sure that you subscribe to the channel. And yeah, of course, let me know if you have any other questions, okay?